So now let's look at some more advanced types of rationalizing the denominator. So let's begin with what you notice up here, and if you can see any pattern. So if you look closely, you will hopefully identify that this is the difference of two squares. And if you can remember, difference of two squares is a minus b. A plus b is the same as saying a squared minus b squared. So every one of these here can be written as this. This would be 4 squared minus root 2 squared. That's going to be 16 minus 2, which equals to 14. You can do the same thing for here. So if you can recognize the pattern, you can just write it as 3 squared minus root 7 squared. That's going to be 9, take away 7, which equals to 2. And over here, difference of two squares again, so 5 squared minus root 2 squared is going to be 25, take away 2, which is 23. So if you can recognize these patterns, you should be able to solve or rationalize the denominators for these values down here. So unlike the previous lesson where our denominator only consisted of one surd, or a surd multiplied with a coefficient at the front, we now have an expression as our denominator. So to rationalize it, the method is the same. We have to multiply the bottom with everything at the bottom, so that's multiplied by 1, and in this case we're going to say plus root 2, because our aim is to form a difference of two squares, and then whatever we do to the bottom we're going to do to the top. So that's going to be 1 plus square root 2, and at the bottom it's nice and easy because you did it up here before. It's going to be 1 squared, which is just 1, minus root 2 squared, which is just going to be 2, and at the top I've got 7 plus 7 plus 7 root 2, and my answer is going to be 7 plus 7 root 2 over minus 1. So that's our answer here. Over here, same thing, we're going to multiply the bottom with 7, and it's going to be minus 1 because we want to make the difference of two squares, and the pattern is minus and a positive. And whatever we do to the bottom, we also do to the top. At the bottom, we know that we've got 7 minus 1 because it's going to be root 7 squared minus 1 squared. So we know it's going to be a 6 later. At the top, we've got root 2 minus 4 multiplied by root 7 minus 1. At the top, if we expand it like we normally would with binomials, we've got root 2 times root 7, which is going to be root 14. Then it's going to be minus root 2, and then it's going to be minus 4 root 7, positive 4. And at the bottom, we've got 6. And we continue. Are there any like terms that we can collect? In this case, we cannot, and I think that's the best that we can do in this instance. It's just a very long term. Last one, we're going to multiply the bottom with 3 root 3 plus 2 root 6. So we're forming the difference of two squares, and at the top we do exactly the same as we did for the bottom, 3 root 3 plus 2 root 6. Now at the bottom we're going to have, let's write it out this time, 3 root 3 squared minus 2 root 6 squared. At the top we can multiply each of these out. So if you imagine that in the bracket, that's going to be multiplied with that, and same with at the bottom here. So 2 root 5 times 3 root 3 is going to give us 6 root 15 plus, in this case, 4 root 30, and then root 3 times 3 root 3 is going to be positive 3 root 9, which is going to end up being a 3 later, and then root 3 times 2 root 6 is going to be positive 2 root 18. So can we simplify this any further? At the top here, we can simplify the 9 into a 3. So that's going to be 3 times 3 over here. And that's going to be 18 can be split into 9 and 2. So we can square root 9. I'll show you down here. So we've got 6 root 15. Can't do anything. Plus 4 root 30. We can't do anything with that one either. Plus, now 3 times root 9 is going to be 9, because it's going to be 3 times 3. Plus, I've got 2, and inside is the same as root 9 times 2. So root 9 is 3, 2 times 3 is 6, and we still have 2 on the inside. And at the bottom, we've got 3 squared, which is 9. Root 3 is 3. And at the over here, we've got 2 squared is 4, and root 6 squared is 6. So at the bottom, we've got 9 times 3, which is 27, take away 24. And at the top, there is nothing else we can simplify at the top, so we just write it as is. So the bottom, the denominator is going to be 3, and everything here is going to be written down there. So 6 root 15 plus 4 root 30 plus 9 plus 6 root 2. And there you have it.